Section 11. We're going to learn how to solve simple radical equations. An equation such as v equals the square root of 2gd is a simple radical equation. It has a radical in it, and there's a variable under the radical. That's what makes it a radical equation. In this case, v is the velocity, g is the force of gravity, and d is the distance in meters from the Earth's surface. And this formula is used to determine the velocity of a free fall of an object. An equation that has a variable in the radical or in the radicand is called a radical equation. Here's the procedure for solving radical equations. 1. Isolate the radical on one side. Get it by itself. 2. Square both sides to get rid of the radical. And 3. Check the answer to make sure it's a true statement. It's very important that you check the answer, because when you square both sides of an equation, you can introduce something called extraneous solutions. These are solutions that really don't work. So you got to make sure that you check your answers. Solve. Square root of m plus 5 equals 1. First, get the radical on one side by itself. It already is isolated. See, there's nothing around it. Next, square both sides. Squaring a radical makes the radical disappear. They undo each other. Square this side, you get 1 squared. M plus 5 is the radicand, or was the radicand. It's equal to 1. M equals -4, because you subtract 5 from both sides. So it seems like the solution is m equals -4, but you got to ask yourself, is it really a solution? Or by squaring it, did we make an equation that wasn't equivalent to the original one? So we have to check. Remember, you have to put it in the original equation. We can't put it here. That'd be the easy way to do it, of course. You got to put it in the original equation. So we're going to put -4, which was m, plus 5, the square root, and we put a little question mark here saying, is it equal to 1? We're asking ourselves, is this going to be a true statement? -4 plus 5 is 1. Square root of 1, is that equal to 1? Well, you take the square root of 1, you get 1. This is a true statement. So therefore, this, -4, is a solution. Let's try another one. Square root of 4x plus 2 equals 6. First, we isolate the radical. Notice that there's a 2 here. It's not isolated. So to get rid of this, we subtract the 2. So we get square root of 4x equals 4. This is the same thing as if you had a plus 2 equals 6. How would you get the a by itself? You would subtract the 2. You're doing the same thing right there, because that is a variable. We do not know what this is because we do not know what x is yet. So we've isolated the variable. Now we're going to square both sides, and once again, the square root and the square undoes each other. 4x is what's left. 4 squared is 16, and x is equal to 4. But you got to ask yourself, is 4 really the solution? Put it back into the original equation. 4 times 4 is 16 plus 2. The question mark means, is this going to be a true statement? Continue on down. We get 4 plus 2. Is that equal to 6? Obviously, it's equal to 6. So x plus 4 is a solution. Little one. Let's try one a little bit harder. Here's the radical equation. We have to get the radical by itself. So we're going to add 2x to both sides. The radical is now isolated. We now square both sides. We're going to square here, and we're going to square this whole thing. Remember, you got to square the whole quantity. Just don't square the x. On this side, the square root and the square sign cancel, and you get the radicand, or what was the radicand left. 2 squared is 4. X squared is x squared. We see we have an x squared over here and x squared over there. We have to combine the like terms. So we subtract 4x squared. Subtract 4x squared here, we get 7x squared. We actually would have 7x squared minus 63 equals 0. I'm going to add 63 to both sides. I'm going to divide by 7. And I'm going to get x squared equals 9. I'm going to take the square root of both sides. I get x equals plus and minus 3. Remember, taking the square root gives you 2 solutions all the time. Now, we have 2 solutions, a plus 3 and a negative 3. You got to ask yourself, are they solutions to the equations? Are one solutions, or maybe none of them are solutions? Put them back into the original equation. 11 times 3 squared minus 63. Minus 2 times 3, we're asking ourselves, is that equal to 0? Well, 3 squared is 9. 9 times 11 is 99. Minus 63. Minus a 6 here. 2 times 3 is 6. Is that equal to 0? 99 minus 63 is 36. Square root of 36 is 6. And it looks like 6 minus 6 is 0. That is a true statement. So therefore, 3 is a solution. And we're not done yet. We have to check the negative 3. 11 times negative 3 squared. This is 99 minus 63. Because remember, negative 3 squared is 9. And 9 times 11 is 99. Minus 63 gives us the square root of 36. Let's see what we have here. Negative 2 times negative 3. That's a positive 6. Bring that down here. The square root of 36 is 6. Plus 6 is equal to 0. Well, I don't think so. 6 plus 6 is 12. So this is not a true statement. So therefore, negative 3 is not a solution. So the solution to your equation will just be a positive 3. Square root of x plus 9 equals 6. Let's do that one. Subtract 9 from both sides, and we get negative 3. The x is now, the radical is now isolated. Square both sides. We get the square root of x squared equals negative 3 squared, which is 9. Squaring a radical makes the radical disappear, and you get x equals 9. That was a very simple equation. Oh, but are we done yet? No. We have to put it back into the original equation to see if it's a true statement. So here we go. We have the square root of 9 plus 9 equals 6. Let's do this here. We have the square root of 9 plus 9, and we're asking ourselves, is that equal to 6? Well, the square root of 9 is 3 plus 9. I don't think that's equal to 6. So we can say that this is not a true statement, and therefore this is not a solution. And since it's the only solution we have, we can say that the equation has not a solution, or has no solution. Think about this second step right here, though, while you're thinking about it. This step right here. When you square root, when you take the principal square root of a number, can you come up with a negative number? There's nothing that you can put in for x, so when you take the square root of it, you get a negative number. That alone should tell you that there's no solution. Also, don't forget that the square root means the principal square root, which is always positive. Let's take a look at this one. The radical is not isolated yet because we have a 4 in front of it. So divide both sides by 4 and you get 9 equals that. Square both sides. We get 81 equals 4m squared plus 5. Subtract the 5 from both sides and we get 76 equals 4m squared. Divide by 4 and you get 19 equals m squared. And m equals square root of 19 or the square root of the negative square root of 19. Now you have to check these to make sure that it's a true statement. So let's look at that. If you put the square root of 19 back into m squared, you can do this in your head, you get 19. 19 times 4 plus 5, the square root times 4 will give you 36. Notice that you put negative 19, negative square root of 19 back into here. Since you're squaring it, you're going to get the same thing. Because it makes no difference whether you square positive square root of 19 or negative square root of 19. Because remember, negative times a negative is a positive. So these two are solutions because they will make a true statement. All right, let's try a couple more examples very quickly. We have the square root of 2x minus 4 over 8. It's a fraction of the radical. Same idea. Square both sides. 2x minus 4 over 8. Multiply both sides by 8 to get rid of the denominator. 2x minus 4 equals 32. Add a 4. 2x equals 36. X equals 18. Is this a solution? Remember what you have to do? You have to check it. So we have 2 times 18 is 36. 36 minus 4 is 32. 32 divided by 8 is 4, and the square root of 4 is 2. So x equals 18 is a solution. Let's take a look at this one. We have two radicals now. But this is not a variable radical. We don't have to worry about this one. Okay? This is the one we have to really worry about. It's isolated. We don't have to isolate this one because there's no variable there. We've isolated the square root of r. It's already isolated, so we square both sides. This becomes r. Now remember, you square both things. Put a parenthesis around it and a square on the outside. 5 squared is 25. The square root of 2 squared is 2. R is equal to 50. Okay, so let's check to make sure it's right. Basically, you put 50 in there, the square root of 50. That's equal to the square root of 25 times 2. The square root of 25 is 5. 5 square root of 2. So it will be true statement if you write it out. Your assignment is page 548, 1 to 50 odd, and a couple story problems, page 549, 1 to 6. There is another video on the wiki that points to a YouTube video that has this same solving equations. So I hope this has been helpful.